Hi guys, welcome to Mr. Gron's Garage. We're talking about arc length today. So what is arc length? Well, it's the distance around part of a circle. It could be the whole way around, it could be halfway around, a part of the way around, whatever. It's just the distance around the edge of a circle from point A to point B. To find this, we need to start out with our circumference formula, 2 pi r. Now for these examples, I am doing these in degrees. We're going to do both degrees and radians, and this first strategy is with degrees. And hopefully, like, coming away from this, you sort of see and understand the pattern here. And really, in the end, I'll give you a formula, but hopefully we don't even really need it because we'll know how to reason towards what the arc length would be and how we can figure it out. So, a couple of scenarios here to start with. Some easier sort of mental math type ones would be like this one, where I'm talking about the entire distance around the circle, or an arc of 360 degrees. Now this circle has radius 1, so it's the whole way around, so my arc length is just the circumference. It's 2 times pi times the radius 1, which is about 6.28. Second scenario here, we've got half the way around a circle, or a 180 degree arc. Radius is still 1. It's a half circle now, so I'm going to do 1/2 times 2 pi times the radius, which would be about 3.14, about pi. Third scenario is a 90 degree arc, or 1/4 of the way around the circle. Well, if it's 1/4 of the way around the circle, I'm going to do 1/4 times the circumference, which is 2 times pi times the radius, and in this case we get about 1.57. So those are 3 scenarios where they're fairly easy ones to sort of figure out what the fraction of a circle is. 180 is half, so you multiply it by half. 90 degrees is 1/4, so you multiply the circumference by 1/4. But what if we had something that wasn't quite as easy to figure out mentally? What if we had something like this? Let's say that our arc, we still have radius 1, but our arc is now about 201 degrees. So maybe about like that. So 201 degree arc. How could I figure that out? Well, I know there's 360 degrees in a circle, so let's take a look back at here and see what happens. If I do 360 over 360 here, that becomes 1, right? So that's the full the full circumference. If I do this one, 180 over 360, well, that's half. 180 divided by 360, it reduces to 1/2, and that's half the distance around the circle. If I do 90 over 360, well, that reduces to 1/4, and so that's why it's 1/4 of the way around the circle. That's why we've got that 1/4 there. So if you see what that pattern is now, 201 over 360, that is sort of the percent or the fraction of the way around the circle I'm going. So whatever this arc is, whatever that arc angle is, that arc measurement, I can make that a fraction of the angle over 360, and then just multiply that by the circumference of the whole circle, or just 2 pi r. And in that case, I did this ahead of time, that equals about 3.51. So coming away from this, what I would like my students to be able to do is just to reason that if I know how to find the distance around the whole circle, if I know what the degrees are of the arc, I should be able to just throw that over 360 and always be able to multiply that and figure it out, even if I don't remember what the actual formula is. If you do want to write down a formula, it would be this. Here's our circle. Oops. We'll make that part dashed. Here's our radius, and our arc length is S. The actual degrees of the arc are theta degrees. The arc length S is going to be equal to theta over 360 times 2 pi r. And there you have it. Now, that is for degrees. It's a slightly different strategy for radians, but it's really kind of the same thing. We've already talked about radians in this class in a previous video, I believe. So I'm going to assume that we know what a radian is and how many radians are in a full circle for these next examples. Alright, so radians. Now, again, I'm going to start this out with some more mental math type ones. Let's say that we've got, this one was still radius 1, and we've got 2 pi radians, so it's the full circle. Well, again, that's 2 pi times 1, the radius is 1, and that's about 6.28. Our half circle is now radius 1. Pi radians makes half of a circle, and that ends up still being 1/2 2 pi times the radius, 3.14. A fourth of the way around is now pi over 2 radians, still radius 1, and we still have 1/4 times 2 pi times our radius 1, which is still about 1.57, okay? Now, with this one, it's a slightly different pattern. It's actually a lot easier with radians if you know what the formula is, and we'll get there in just a second. So again, these are really like nice ones where I can visually see, okay, it's a full, it's a half, it's a fourth, but what if we get something uglier like this? Something like 31 pi over 45 radians, still radius 1. I think that's about how far it is. I honestly don't know. That's a tough one to sort of visualize. Maybe it's a little bit further. Maybe it's more like that. That looks a little better to me. So, how am I going to do this one? Well, before I tackle this, I'm going to take a look back at these ones and see if I can figure out a pattern here. 2 pi are the number of radians. 2 pi is in my formula. Pi radians, let's see, if I take 1/2 times 2 pi, those cancel out, and now it's pi. And on this one, it's a quarter of a circle for pi over 2. The 4 and the 2 can reduce to 1/2, which would make it pi over 2 times the radius, still equals 1.57. 2 over 4 reduces to 1 over 2 times pi is pi over 2, right? So the pattern here is that it seems like we're just multiplying the radians times the radius. Now maybe that's just a nice convenient thing because these are easy ones. What about something like this? Well, I know that 31 pi over 45, to figure out the fraction of the way around, if it was in degrees, I'd divide this by 360, but now it's in radians, so I'll have to divide it by 2 pi. So I can do that by sneaking a little 2 pi down in the bottom here of the denominator. That's the same as dividing it by 2 pi. And now I'll multiply that by 2 pi times the radius. We'll look at what happens. The 2 pi's cancel out, and again, all it is whatever that measurement is as a radian, in radians, times the radius. And in this case, that is about 2.16. So our formula in this case, if we have it in radians, looks like this. There's my deal. There's my radius. S is still the arc length around here. Now I have theta in terms of radians, and in that case my formula is just that the arc length is equal to theta times the radius. So there you have it. 2 forms, degrees, radians. I think at this point, hopefully we see the patterns, and then when, you know, your pre-calc teacher says you have to write down this formula and memorize it, you say, I don't really need to do that because I know how many degrees and I know how many radians and I know how to use fractions to figure out to figure out how far, what percent, what fraction of the circle this makes up, and I can just multiply that by the whole thing to figure out what the arc length is.